Pluto, the most misunderstood world in the solar system. In 2015, when NASA's New Horizons spacecraft flew past Pluto and transmitted its first clear images back to Earth, the scientific world was shaken. These data revealed that Pluto was far more complex, dynamic, and mysterious than previously imagined. Once dismissed as a frozen, lifeless rock, Pluto turned out to be a world that is still geologically active. On Pluto's surface, scientists discovered vast plains made of nitrogen ice, mountains composed of water ice, icy rock formations, and regions that appeared surprisingly young. One area in particular, the heart-shaped region known as Sputnik Planitia, showed almost no impact craters. This suggested that the surface may be only tens of millions of years old, an astonishing finding for such a small dwarf world located at the edge of the solar system. Is Pluto still geologically alive? The polygonal patterns observed on the surface of Sputnik Planitia may look like cracks at first glance, but they are actually caused by convection within nitrogen ice. This points to the presence of an internal heat source still active within Pluto. Along the edges of these plains rise mountains several kilometers high. These mountains are not made of rock, but of water ice, which, under Pluto's extreme cold, becomes as hard as granite. One of the most remarkable discoveries was the presence of cryovolcanoes. Structures known as Wright Mons and Picard Mons suggest eruptions not of molten lava, but of water, ammonia, and methane. This provides strong evidence that Pluto was once, and may still be, internally active. Organic chemistry and atmosphere. Although Pluto's atmosphere is extremely thin, it is surprisingly complex. It is composed mainly of nitrogen, with smaller amounts of methane and carbon monoxide. New Horizons detected more than 20 distinct haze layers in the atmosphere, stacked one above another in images taken with the Sun behind Pluto. The atmosphere of this dwarf planet changes over time. As Pluto moves closer to the Sun, frozen surface gases sublimate and form a thin atmosphere. As it travels farther away, the atmosphere freezes and falls back onto the surface. These cycles drive climate changes that unfold over centuries. When methane interacts with cosmic radiation, it transforms into complex organic molecules known as tholins. These substances give Pluto's surface a reddish hue and are linked to chemical processes considered fundamental to the origins of life. The dark region called Cthulhu Macula is one of Pluto's oldest and most organic-rich areas. Could Pluto be hiding an ocean? One of Pluto's greatest mysteries is whether a liquid water ocean exists beneath its icy surface. If an ancient ocean had completely frozen, global fractures would be visible on the surface. However, regions like Sputnik Planitia show no such features. This suggests that the surface may still be supported by a softer or even liquid layer below. Radioactive elements such as uranium and thorium within Pluto's core may provide a long-lasting internal energy source. When combined with natural antifreezes like ammonia, this heat could allow liquid water to persist beneath the ice. Another intriguing clue is the location of Sputnik Planitia, which lies almost directly opposite Pluto's largest moon, Charon. This alignment can be explained if a dense subsurface mass, possibly an ocean, exists beneath the basin. The Pluto-Charon system and other moons. Pluto and Charon are considered the only known binary dwarf planet system in the solar system. The center of mass between them lies outside Pluto, and both bodies are tidally locked, constantly showing the same face to each other. Large fractures on Charon's surface may be remnants of an ancient internal ocean that froze and expanded. A reddish region near Charon's north pole is believed to be formed from methane escaping Pluto and transforming into tholins under radiation. Pluto's four smaller moons, Nix, Hydra, Kerberos, and Styx, are irregular in shape yet orbit in nearly perfect circles. However, they rotate chaotically, making them some of the most unusual moons in the solar system. New Horizons, the first journey to touch Pluto. On January 19, 2006, while debates over Pluto's planetary status were still ongoing, NASA launched one of its boldest missions. New Horizons set off on a journey toward Pluto. For nearly 9 years, it traveled silently through the darkness of space. Then, in July 2015, as it passed by Pluto, humanity saw this distant world up close for the first time. The images changed everything. Pluto was not dead. It was frozen, but not motionless. Young surfaces, flowing ice, towering mountains, and a complex atmosphere were revealed. But the journey did not end there. Today, New Horizons continues its voyage. Powered by a slowly fading nuclear energy source. It is expected to keep sending data from deep space until around 2030. Conclusion: why does Pluto matter? Pluto does not have to be a planet. This small world reminds us how full of surprises the universe still is, and why we should never forget one simple truth. Sometimes, the smallest places ask the biggest questions.